Welcome back. This is the second lesson recording for IM2, December 14th, 2020. So we've just done the congruence triangle, and now let's compare that to similar triangles. Okay, now we're told that triangle CDE is similar to FGH. So then angle G and angle D are, what do we know about angle G and angle D? Well, they are the same letter. They are both the middle letters. That means they're the corresponding. Angle G and angle D are corresponding. That means we know that the angles, corresponding angles of similar triangles are always congruent. So the angles are going to be congruent. Remember, with similar triangles, the corresponding angles are congruent, but the sides are proportional, side length are proportional. In contrast to the congruent triangles, the corresponding angles are congruent and the side lengths are also congruent. But the side length for the similar triangles are just proportional. Okay, what about the next one? Angle G and angle C. Angle G and angle C. They're in this different position, right? That means angle G and angle C, they do not necessarily have to be the same. It could be the same, but they do not necessarily have to be the same. So they're not proportional. We don't know for sure they're congruent. So all we can say is we don't know. Okay, then let's talk about the final problem. GF and CD. Where is GF? GF is the first two letters and CD is the first two letters. That means GF, where is GF? GF is this side, and CD, this side, they're corresponding. So do we know that they are the same in measure? No, we do not. So that's actually wrong. I should just put one notch there because they're not necessarily the same. They could be the same, but they're not necessarily the same. However, since they are corresponding, they are proportional. Okay, so what do we know? Well, let's compare. So congruent and similar, the corresponding angles are both going to be congruent. When the angles are not corresponding, we don't know for both of them. But the side length, the measures for congruent triangles are going to be congruent, while as side measures for corresponding side measures of similar triangles are going to be proportional. That means however long this is over this length is going to be same as this length to this length over. Okay, so this was the slide that you could draw on. And you are supposed to determine if the two triangles are similar. If they are, select the reason how you know. Remember, for triangle similarity, corresponding angles are congruent, but the corresponding sides are proportional. Okay, so the possible shortcuts are if you have two angles that are two corresponding angle pairs that are congruent, or side, 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 all three sides are proportional, or two sides and the included angle. Two sides are proportional and the included angle is congruent. So let's see what we have. Well, what do we have? We have the possible similarity shortcut we could have is we are given two sides and the included angle. So the possible one is SAS. But before we can do that, because it's SAS because we know that the vertical angles are always going to be congruent. Okay, so then if that is the case, we know the angles check out, so we need to check the two sides. All right, so this 32 and 28, which is the biggest, longer side, It's 32, which is the longer side of 8 and 7. It's 8. So we are looking at 32 divided by 8. Is that proportion same as 28 divided by 7? Because they are the corresponding sides. Well, 32 divided by 8 is 4, and 28 divided by 7 is also 4. So yes, they are proportional. So we have two sides that are proportional, two corresponding pairs of sides are proportional, and the included angle that is congruent. So it's by SAS similarity that they are similar. What about this case? Again, we know that the vertical angles are going to be the same. So we know that this is going to be the same. Okay. Now, what about the side length? It's possibly SAS, okay, because we're given two sides, two pairs of sides, and the included angle. So let's check that. So we have which is the longer side between 121 and 132, it's 72. So we need to match that up. So 132 over 72, what is that? And 121 over 66, what is that? And when I use the calculator, I get 1.833 continuous for both of them. That means they both have they are the same, right? So that means the sides, corresponding sides are proportional, and the included angle is congruent. So it is also by SAS. They are similar. Okay. What about number 3? We know that the angles vertical angles are going to be always congruent. We're also told that another pair of angle is congruent. Okay, so that means we have one pair and another pair. So it's by angle similarity. With if you have two angles that are similar, congruent, then we don't even have to check for anything else. Okay, what about this? Okay, the only possibility is we are only given the sides. We are given 3 sides. So that means it's possibly side by side. So we need to match up the sides. The longest side is 42. The longest side here is 28. 42 over 28 will be one proportion. Okay, and then the middle side is 39 and 28. And finally, the shorter side is 33 and 22. Okay, make sure you do not flip the fractions. I am going from always the bottom triangle at the top. And if I use the calculator, I get 1.5, 1.39, and 1.5. When I found 1.39, I did not even have to go to find the third ratio because this has already failed. The sides are not proportional because they have different ratio. So this is not similar. Okay, so this time we have to find the missing side length. We're told that triangle RGH is similar to triangle RST. So RGH is the smaller triangle and RST is the bigger triangle. So since we know that they're similar, then we know that the proportions are going to be the same. So we know that 50 over 70, well, let's call this X. Okay, so 50 over 70 over 70. So the small triangle side length divided by the longer side is going to be 45 over X. Okay, so because we're told that they're similar, the ratio has to be the same. So from here, what do? We can cross multiply. That's because we have one fraction being equal to another fraction. So that becomes 50x is equal to 70 times 45. Okay, actually we should have canceled the zeros out first just to make our math a little easier. So that means 5x, well, we can actually divide both sides by 5 here. Oops. Let's divide both sides by 5 just to make it easier. So then that's going to become, this is going to cancel out to be 9. 9 times 7 is 63. So I know that question mark is 63 units. What about this one time? DEF is similar to QRS. DEF is similar to QRS. Okay, so we need to figure out which side corresponds to which. And you cannot just always go by the drawing. You really do need to go from the similarity statement because sometimes if the side lengths are not very different, you're not going to be able to tell which is longer or which is shorter, right? So in this case, it's kind of hard to tell for sure that this is the shorter side. So we're going to go with RQ. RQ is the first two letters and they corresponds to DE. DE, RQ and DE corresponds to each other. They're not same, but they are corresponding. So I can say 21 over x plus 15 is going to be equal to SR. SR is FE, FE. They are corresponding, making sure. So 27 divided by 36. Okay, and I can simplify this fraction as they're both divisible by 9. So divide by 9 and divide by 9, that simplifies to 3 over 4. Okay, so then at this point, I can cross multiply and that's going to be much easier with a smaller number. So I am left with 3 times x plus 15 is going to be equal to 21 times 4. And 21 times 4, I can divide both sides by 3 here and divide both sides by 3. 21 divided by 3 is going to be 7. 7 times 4 is 28 is equal to x plus 15. Subtract 15 from both sides leaves me with x is equal to 13. Okay, next problem. Write the equation that can be used to solve for x. What are we given? We're given this side length, another side length, and another side length of a right angle triangle. What can we use when we're given 3 different side lengths? When we're dealing with 3 different side lengths, it's the Pythagorean theorem that says leg 1 square plus leg 2 square equals hypotenuse square. Which is the hypotenuse? That's the 13 because that's across from the right angle. So that means that we have the equation x squared plus 4 squared is equal to 13 squared. So x squared plus 4 squared is 16 is equal to 169. Okay, so then subtract 16 from both sides leaves me with x squared is equal to 3 and 553. And then I need to look to see. Now, is this divisible by 4 or is it divisible by 9? It is divisible by 9 actually. So x squared is going to be Oh, actually, we're going to take a square root of both sides here.